only based on your results of questions that I give you. So if you can solve certain kinds of problems, then I can go on and we can pretty much cover everything that I know you need to know, with or without that other list.
Okay, cool.
So I'm just going to give you some problems here. I'm going to get them out of the book.
Okay.
You tell me. You don't need to tell me what you're going to do. What I'd like you to just tell me is give me the next line.
Okay, so it'd be 3 over 7x is equal to 6.
Again?
And then you would just divide 6 by 3/7.
So give me the answer.
So it's 3 over 7 divided by
Well, now,
6.
First of all, you said divide both sides by 3/7. Okay?
Yeah.
Which is correct. I can do that. It's just awfully messy looking.
Yeah, I agree.
So
you can make it 6 over 1.
What it is we're actually doing here is we're not really going to divide both sides by 3/7. We're going to multiply both sides by 7, and then we're going to divide both sides by 3. So what we're really going to do, if you want to do it all in one step, is we're going to multiply by the reciprocal.
Okay.
That's what you're doing.
Oh, okay.
Okay? And that's not nearly as messy as the other way. In other words,
that makes sense.
if we're dividing by 3/7, we're going to flip and multiply.
Yeah, exactly.
We're just going to go directly to that step. And notice how convenient this is for the left side. The 7s cancel, the 3s cancel, and you're left with x. How am I going to do
is equal, you do 6 times 7, which is 42, divided by 3 is 14.
I'd like you to do it a different way. Whenever you see a problem like this, with or without calculators, let's see if we can reduce the size of the numbers. That's always the goal, is to work with small numbers. Well, what's 6 over 3?
2.
So I can replace that with a 2.
Oh, and then divide.
2 times 7 is 14.
Yeah.
In other words, by doing that, I didn't have to deal with any number greater than 14.
Yeah.
Whereas the other way, I would have been having 42 divided by 3, and then I would have probably needed to pull out a calculator to do that, to get 14. So, one thing always do in these problems that I'm gonna give you is reduce.
Okay.
Before going further.
Okay. Cool.
I love algebra. It just is, once you figure out the methodology that you're going to do, then it's all pretty much falls into place.
Exactly.
Whatever you get is what you get.
Exactly. Yeah.
So you can do this in however many steps you need, but give me a next line.
Okay. So 11 is equal to 2n minus 9. Then you would add 9. That'd be 20 is equal to 2n and is equal to 10. Cool.
You're going to like today, because I know you like algebra.
Yeah, it's my strong suit.
It's always more fun to do something that you understand and that you enjoy rather than geometry.
Exactly.
Right. Just give me the next line, and you can do it however, like I said. I prefer one set of steps at a time. I think a big mistake a lot of people make in doing algebra is trying to do multiple stuff all at once.
Yeah. Yeah. Okay. So the next line would be 12x minus 20 is equal to 2x minus 16 minus x minus 6x.
Okay. Next line.
8x minus 36. 8x is equal to minus 36.
Okay. Where are you getting the 8x from?
Well, 12.
Well, first of all, let me ask you, are you combining all x's in one step?
Yeah. Yeah. Can you do that?
Yes, absolutely.
Okay.
Okay, I was just not with you. Okay, you were a step ahead of me. What else?
Okay.
I'm sorry.
8x is equal to negative 36. Is that, wait, negative 20 minus 16
Okay,
would be,
this is a common error that you've made in the past. I remember it from last year, actually.
okay.
Always remember, you have to do the opposite. You're not subtracting 20 from the right side.
Oh, so you're at, well, yeah, we could add 16, yeah.
No,
Yeah,
I'm adding 20.
or 20, yeah.
Yeah,
Okay.
in other words, you've already brought the x's over to the left side.
Okay.
Okay? And we got a positive coefficient, which says you brought them to the correct side.
Okay.
We didn't do the math correct, though, and you made the same mistake there. Let's do this in two steps.
Okay.
12x minus 20. Let's combine the x's.
Okay. Minus 4x. Minus 16.
Okay.
There we go.
Now,
Okay.
now let's move all the x's to whichever side gives it a positive coefficient.
Okay, so we would add 4 to both sides.
Exactly.
Okay.
16 must have been why I got confused originally, as I couldn't come up with the 8.
Yeah.
And then you convinced me 8 was correct.
Okay.
That's not an easy thing to do, is to convince a tutor that you're incorrect and
Yeah.
correct.
Yeah.
Okay. So,
Alright.
now what? What's on the
Yeah, so it'd be 16x is equal to, we could add 16 to both sides.
No, remember that one of the goals here is to get our variables on one side, our numbers on the other.
Oh,
We're not going to add 16 to both sides. That would put everything on the left side.
So we add 4. Okay, so it'd be 16x is equal to negative 6. Well,
go ahead. Negative 6.
Yes.
What?
Yeah.
Plus.
Negative 20.
Right. Okay. Now here's what we did a year ago when this was a problem for you.
Uh-huh.
Is we did it the way they teach it.
Yeah.
It's one step that I kind of like dispensing with, but until you get it so you're 99% of the time correct, let's do it this way.
Okay.
Okay? Because now it's clear that those cancel one another.
Uh-huh. Okay.
We got rid of that already when we moved it over.
Uh-huh.
No, we didn't.
Wait.
Have to add. So that's 16x.
Yes, it'd be...
And it's equal to 4. So what's x equal to?
So 16x is equal to 4x is equal to 4. Wait.
Again.
I'm looking at it. I'm looking at it the wrong way. So it would be x is equal to 16.
Okay, that's the same problem as the other one.
Yeah.
In other words, what you have to do when solving algebra equations is the inverse, the opposite of what that thing is doing.
Okay.
In other words, if we're multiplying by 12, we're going to end up dividing by 12 to get rid of the 12. If we're subtracting 20, then we have to add 20.
Yeah.
If we're subtracting 16, we have to add 16.
Yeah, exactly.
Here we have to divide by 16, both sides.
Uh-huh.
So, in the same way that we did the other, there's a reason they teach it like they do.
Mm-hmm.
Beginning to realize is because you can't make that mistake. Now, what's x equal to? What's 4 over 16?
2 over 8, which is 1 over 4.
Okay.
Cool.
Also, in using this book that I'm using, I can give you homework. You know, I'm not a big fan of giving you homework, but that's what your father has asked me to do.
Okay.
And so I will email you some problems to do in between our sessions, and I'll just pull them straight out of this algebra book that I have here. I'll just take some pictures of problems and I'll send them to you, and you can work on them between our sessions.
Okay.
That should satisfy him, and it actually does make a good deal of sense also. Whenever you're getting taught anything, you need in-between time to practice it on your just like if you were getting golf lessons or something, you'd want time to go out to the range and hit balls in between lessons.
Yeah.
So.
Yeah, exactly. Okay.
Okay. So, I've got a number of choices on these. This type of problem. What's your first inclination to do?
We could subtract x from both sides.
Correct.
So that make it 1/2 x, right? Or
that's the problem. Is that when we start dealing with fractional x's and whole x's, it trips people up. Because you would have to solve this problem. What is this equal to? Okay? And that surprisingly gives people a lot of trouble, even though it shouldn't. And we'll go through why this gives people trouble. But there's an easy remedy for all of these fractions. That's what I'd like you to think about, is that when you're solving equations, two of my priorities are get rid of denominators. If you have an easy way to get rid of denominators, you should do it almost immediately as a first step. And another step is get rid of parentheses. Now, it isn't always correct to do them in a, 1-2 order, but there's a case where we have a problem that's fairly complicated because we have all these fractions. Do we really want to combine 1/3 x and x, but then we have to also combine 1/4 with 1/6? All that's a pain in the you-know-what.
Yeah,
so,
for sure.
What if we multiplied every term by 12?
Okay. Yeah, because they all equal 12.
So what I'm really gonna do is multiply the left side of the equation by 12 and the right side of the equation by 12. Okay? I'm allowed to do that. That's fundamental rules of algebra. That's what makes algebra so much fun, is that you can do whatever you want to either side as long as you do it to both sides. Okay. Now, what that means is we're really multiplying every single term by 12. In other words, we have to multiply that term by 12, we have to multiply that term by 12, this term, and this term. Okay? That's what we're actually doing. So if the next stage is to get rid of parentheses.
Uh-huh.
Okay, what's
Yeah.
12 times 1/3 x?
4x.
It's 12 times 1/4.
3
It's 12 times
is equal to
x.
12x minus 2.
Now, all of a sudden we go from a hard problem to a super simple looking problem.
Exactly.
That's the beauty of getting rid of denominators.
Yeah, for sure.
Okay, finish this problem.
So we could subtract 4x from each side, which would make it 3 is equal to 8x minus 2.
Okay.
And then add 2 to both sides. So it'd be 5 is equal to 8x. And then x is equal to 5 over 8.
And then divide both sides by 8.
Or yeah.
Let's stick with that. I think for a while, let's stick with that.
Uh-huh.
Okay?
Yeah.
And then
Okay.
at some point, you won't need to do that step. But
Okay.
I'm looking for more problems here. Kind
No,
of
you're good.
advancing the
Okay.
bunch that I can take a picture of and send them to you. That'll be easy homework. But let's go on for this hour.
Okay.
Go to the next subchapter.
Okay.
All right. Writing equations with more than one variable. In other words, everything we just did was one variable only, whether it was x or n, which means you could solve it. In other words, as long as you have one variable and one equation, you can come up with a number. If you add a second variable, now I cannot solve for x and y.
You have to solve for them separately.
Well, there's an infinite number of solutions.
Yeah.
Truly are. I mean, if I allow positive and negative numbers, then there are an infinite number of solutions. But what I can do is solve the equation for y in terms of x. So I can isolate, or I could also solve for x in terms of y. But the standard convention is to solve for y in terms of x.
Okay.
So what am I going to do here as a first step?
We could set 7x equal to 8 first. Well, do you have to solve for them, like, separately?
Okay, our goal is going to be end up with y equals something over here. Okay, and everything that's over here will be everything that's not y. We can call that not y. So anything with x in it, anything with numbers in it, has to end up over there. Okay, so our goal is to isolate this. So what I generally do is just start getting rid of everything else. Okay, so if my goal, and don't worry about the negative sign. If it starts out with a negative sign, let's just ignore it. But I don't mean ignore it. I mean, let's not put the y on the other side. One of our rules let's use is let's put the y on the left side, because we do want to end up with y equals something. We don't want it to be the other way around. It would be just as valid, but let's just follow conventions. So what's the first step going to be?
So if we want to isolate y, so we would
get rid of everything that is not y.
So just subtract 7x from both sides. Oh, okay.
Get rid of the stuff that is being added or subtracted to y at the moment. Okay. So now we're down to that. Now what?
We could.
In other words, we're down to this.
Add 3, yeah. So 3y is equal to, yeah.
Minus 3y. You can't drop
Could
the
we,
negative sign.
yeah, so could we add 3y?
Well,
Oh,
you could, but then
uh,
you'd be left with 0 equals that,
yeah,
and that's kind of what we started with, right?
yeah,
In
exactly,
other words, we're
yeah.
not solving for y. So
Uh-huh,
if I add 3y, the problem is I'm not left with y on the left side anymore.
uh-uh,
I could add 2y, I could add 4y.
uh-huh.
Notice what would happen if I add 4y.
It'd be 1y,
I would get my
just y,
y
yeah.
on the left, but now the
Uh-huh,
problem is I got y's on the other side,
yeah, exactly.
and that's not a solution. In order
No,
for you to solve it, you have to get all the y's on the left side isolated down to 1y, and everything else has to be x or numbers.
okay,
So that's not what we want to do.
no.
What's the rule? We take whatever it is we want to get rid of.
Uh-huh.
What is it doing right now?
It's, well, it's isolating.
Multiplying.
Oh, it's
Is
multiplying.
it not?
Yeah, it's
In other words, what
multiplying,
this
yeah.
expression says is that we're taking y and multiplying it by minus 3.
Yeah, exactly.
Okay? So,
Okay.
if it's a multiplier, what do we want to do to get rid of it?
Put parentheses around y.
Divide.
Oh, divide the opposite, yeah.
Just
Okay.
always do the opposite. And you might as well divide by minus 3.
Uh-huh.
Because we want to have what's left be exactly y.
Okay.
Okay, so I have to divide that by minus 3. I have to divide that by minus 3. Now, I
Okay.
could have just done it in one step. That's the same thing.
Uh-huh.
Is all I'm doing is doing 2 steps in one by breaking it into 2 fractions,
Yeah.
because I want to break it into, I'm going to want to do that at one point. So now I
Uh-huh.
have my y on the left side, all alone,
Okay.
and I have what on the right side?
8 over negative 3 minus,
Let's not
oh,
write it like that. How should that be written?
uh,
Let's put the negative
oh,
sign out in front.
okay.
That's negative 8/3. In other words,
Um,
all of these are the same. 8 over negative 3 is the same as negative 8 over 3, which is the same as the negative in the front, 8/3.
yeah.
This is how you want to end up writing it. Whatever the sign
Yeah,
on the fraction is, that's how you want to write it.
okay.
And
Is equal, okay.
what's the rest of it?
Minus 7x thirds.
Okay, let's reduce that.
Can you reduce that?
Yeah, in other
Oh,
words,
7 equal
that
21.
becomes a positive.
Oh,
So
okay.
that's the same as this, 7/3 x. Okay?
Oh, okay.
And that's
Yeah.
important to do. In other
Uh-huh.
words, you'll get the sign wrong if you don't do that.
Yeah.
So, now, whether or not we do the last step or not, here's what most people would do. They usually want your form to be in y equal mx plus b format, correct?
Yeah. Uh-huh.
What,
Yeah.
what's m in our equation?
M is 7 thirds.
What's b?
Uh, negative 8 thirds.
Correct. In other
Okay.
words, is all I do is transpose those two, which we're allowed to do because they're being added, so I can reverse them.
Yeah.
And this is the more suitable format, y equal mx plus b. The beauty of this format is it allows you to graph it instantly.
Uh-huh.
And that's where we're going next, is graphing when you have an equation with 2 variables.
Okay. Okay.
Um, okay.
Okay.
I'm just looking for more problems. So here's
Sure.
more types of problems. Gradually going to get harder because I'm advancing through this chapter.
Yeah. Okay.
Solve for y. These are always going to be solved for y. Actually, it would be much harder to solve for x, but
yeah.
We can do either. Let's first solve for y.
Okay, so it's x plus xy. We can subtract x.
Okay.
From that side, yeah. From both sides. So it'd be xy is equal to 1 minus x. And then we could put parentheses around y. Like multiply y.
Don't need parentheses. In fact, my goal is to always get rid of parentheses.
Okay.
How close is y to being isolated right now?
We just have to get rid of x.
Okay.
In front of it.
Get rid of x. What is x doing to y right now?
Multiplying, so we have to divide x.
Divide by x.
By x, yeah. So we would get y is equal to, 1 minus x over x.
Yeah, and that's a suitable answer.
Yeah.
I could also turn that into two fractions, so I had 1 over x minus 1. In other words, it could also look like this, but you don't have to do that. That's not necessarily preferred over that.
Yeah.
I guess in my book, I would prefer the first one. I wouldn't automatically break those down into fractions.
Yeah.
Not unless you're trying to put it in y equal mx plus b format, then maybe.
Okay. Alright.
This is temperature in Fahrenheit.
Okay.
Equals 9/5 times the temperature in centigrade plus 32.
Okay.
So if I gave you the temperature in centigrade, the problem would be pretty easy, right?
Yeah.
Okay. But what if I give you the temperature in Fahrenheit, then I say solve for centigrade? So
It's gonna be a little harder.
What I'd like you to do is solve this equation for C.
Okay.
You can leave it on the right side. That's okay. You don't have to move it to the left. Part of the problem with moving it to the left is that all of a sudden we're going to have a negative sign in front of it. So for the moment, let's leave it on the right and solve it for C.
Okay.
First step.
Let's see here. We could subtract 32.
Okay.
From both sides.
So now we have f minus 32 equals 9/5 C. So now we're down to here. Okay.
Okay. And then
partly why I don't like doing this is it messes up your page. You need more page space.
Yeah, exactly.
I write big enough as it is, so I need as much space as I can get. But
yeah.
Okay, now how do I isolate C? What's the trick? It's being multiplied by a fraction, right?
Yeah, so we'd have to divide.
Well, okay, but that's the hard way to look at it. Remember, if I do that, now that becomes an issue, right?
Yeah, it does.
The shortcut?
Just multiply.
Multiplying by the reciprocal.
Yeah.
So
it'd be 5/9.
By 5/9.
Yeah.
So this is one case where it's being multiplied by a fraction, and I'm telling you to multiply by the reciprocal. But it's not really a violation of my rule. My rule is you got to do the opposite. Well,
Yeah.
multiplying by the reciprocal is dividing by 9/5.
Uh-huh.
That's how you would divide by 9/5 is to multiply by the reciprocal.
Okay.
So it's really following the same rule.
Yeah.
Okay, and then I have to multiply this by 5/9 also.
Uh-huh. Okay.
It's funny, I had to look twice because I wrote it like that,
Uh-huh.
wasn't sure whether I had multiplied by 9/5 or 5/9. I knew I had multiplied by one of them, but by writing it on the right side, I confused myself. So it is 5/9, okay? Well, that leaves C all by itself because the 5 cancels and the 9 cancels. We knew that was going to happen.
Yeah.
So this is an acceptable answer, although this should probably be distributed.
Okay.
So a more acceptable answer would be 5/9 F minus 169.
Okay.
So now if I told you that the temperature was 72 degrees in here,
Uh-huh.
you could immediately solve that, substituting 72 for F, and you would have what the centigrade temperature was.
Cool. Okay.
All right. Solve this for W. That's the definition for the perimeter of a rectangle. It's
Okay.
2 times the length plus 2 times the width. What's the width equal to in terms of the other two variables?
4.
Let's go through it step by step. What's the first step?
Um.
Trying to solve for W.
Okay, so we'd subtract 2L from both sides.
So now we have P minus 2L. Okay.
Okay.
And then that goes away.
Uh-huh.
Now what?
So we got P minus 2L is equal to 2W. So we would divide by 2W on both sides.
Not 2W. Remember what we're trying to do. We're trying to end up with W on the right side. If I divide by 2W, I'm going to end up with 1, the number 1 on the right side.
Okay.
So it's always important to only divide by what you're trying to get rid of.
Okay.
We're trying to lose the 2.
Uh-huh.
So we want to divide the 2 as a multiplier, so therefore we want to divide by.
Okay.
So there's our answer.
Okay. Gotcha. Okay.
Oh yeah, now I'm going to be able to give you good kinds of homework.
Cool.
Yeah, just what you wanted to hear. At least I can come up with some problems. I can't believe that other website. That other website's, well,
Yeah.
I'm going to be able to use it to know the subject material you know, but is all I have to do is start from chapter 1 in this book and work my way forward, and we're going to cover everything you need to know.
Uh-huh. Yeah.
Um, trying to think here what they're looking for in these problems. Just a second.
Uh-huh. Okay.
Let's talk about inequalities.
Okay.
No, sorry, hold on.
Okay.
think you need much practice here, but let's just go through it.
Sure.
Five y minus 8 is less than 12.
Alright, so we would add 8 to both sides. So 5y is less than 20. And then y would be less than 4. Alright, so we could subtract 5 from both sides. So we would get 3x, negative 3x is greater than negative 5.
Okay, hold on. You said subtract 5 from both sides.
Or no, so subtract 10 from both sides.
Okay. In other words,
Did I say 5?
Which
Oh, my
you
bad.
do.
Yeah.
No, you can absolutely do that, but that's going to leave 0 on one side.
Yeah, exactly.
About to launch into one of the important concepts of solving equations or inequalities is you want your variables on one side, your numbers on the other. So you wouldn't want to subtract 5 from both sides. That would put both things on the same side of the equation. Or
Okay.
inequality. But by subtracting 10 from both sides, now you have the variables on one side and you have the numbers on the other, almost all of them, not quite all of them.
Yeah.
Next step.
And then the next step would be you would divide negative 3x on both sides, so it would be.
I want you to verbalize it properly.
Okay.
Not dividing negative 3x on both sides.
Okay.
You're dividing both sides by what?
Negative 3.
Okay. Which is a lot different than what you said.
Yeah.
And what else do we have to do because we divided by a negative number?
You have to multiply.
You have to reverse the direction of the sign.
Oh, yeah. Yeah, that's right. Okay.
That's pretty much the only difference between inequalities and equations is that you got to be careful when you divide or multiply by a negative number. You have to change the direction. Not if you add or subtract negative numbers. It's only if you multiply or divide. So what's my final answer?
So it'd be x is less than negative 5 over 3. Cool.
No, that's not right.
Oh, that's not right, my bad.
Less than 5/3.
Oh, that's right, because it's yeah.
You cancel. In other words, negative divided by negative, you always need to simplify that.
Okay.
Okay?
Okay.
Now, there is one other case that's a little strange for inequalities. First of all, let's talk about inequality.
Okay.
Solve that.
X squared is equal to 4. My brain just went blank on me.
What do you do to both sides in order to get that left side to just x?
Square it. Square 4.
It's being squared now. In other words, the number we're trying to get rid of is that one, right?
So you would find the square root.
Ah, there you go. In other words, what's the inverse of squaring something? It's taking the square root of it.
Yeah.
So I'm going to take the square root of it, but I don't really want to show it to you like that because now you're going to give me the wrong answer on the right. So let's not do it that way. Let's take the square root of it by doing this.
Okay.
Now you end up with x on the left, but you get the proper plus or minus 2 answer on the right.
Okay.
So you don't need to write it like that.
Yeah.
But you'd be amazed at how difficult it is to teach students that when you take the square root of both sides of an equation, your answer always needs to begin with the words plus or minus.
Uh-huh.
Wish I could sing it, but no, A, B,
Okay.
C, D, E, F, G. But because I guarantee you could take 100 graduates from high school and give them this equation, and 95 of them are going to say x equals 2.
Yeah, and they won't put the plus or minus.
5 of them will get it right. And I'm talking
Yeah.
about graduates.
Uh-huh.
That's how.
Wow.
Now, if I have this,
Uh-huh. Oh,
notice,
you would do, ooh,
yeah,
I can know.
this is a little confusing, as it should be, because I'm not dividing by a negative number, but
No.
I'm going to take the square root of both sides, so what's my answer going to be? Well, my answer actually is going to be
Greater than or equal to.
greater than the positive one or less than the negative one.
Okay, so it's two answers.
Right. Well,
Yeah.
the equation is two answers also. When I had
Uh-huh.
x squared equal to 4, my answer was x equal plus 2 or x equal minus 2.
Okay.
So it's no different in that respect. But notice that I had to not only come up with a plus or minus 2, but I had to get the direction of the inequality correct.
Yeah.
And that's not that easy to see, but notice that if x was less than minus 2, let's say x is minus 3,
Uh-huh.
well, when you square minus 3, you get positive 9. So 9 is greater than 4. So you can
Yeah.
always do a little check in your mind by substituting some numbers. Make sure that this is the correct way to solve that.
Okay.
But
Yeah.
I guess you could say that make the greater than. Of course, if it's less than 2, then I got to do the reverse here. Then it's either less than 2 or greater than minus 2.
Okay.
But
Interesting.
so just remember that when you have inequalities and you're taking the square root of both sides, you have
Uh-huh.
to do strange things to them.
Yeah.
And the way to figure out the correct thing to do is to actually try some numbers to make sure you've done it correctly.
Okay.
Let's talk about graphing inequalities
Okay.
on a number line. You know how to do these, but I'll give you one or two just to make sure.
Sure.
So if x is greater than or equal to minus 4 and less than or equal to 4, how do I graph that on a number line? If that's negative 4 there, that's 0, that's positive 4. What's my graph going to look like?
It's gonna be a. So you're just gonna put. Ooh. You put just like a connect two dots, right? Just over negative
Okay.
4 and positive 4.
Yep, it's the dots can either be open or closed.
And in this case, they'd be closed because it's equal, because there's an equal sign.
Okay. Now, I'm not done. In
No.
other words, I still have to tell whoever's looking at this whether I'm outside these dots or inside these dots or in just certain areas. So I do need to connect those two right there.
Yeah.
How dark you make that line is up to you.
Okay.
But that would be a different solution than that or that.
Yeah,
So
exactly.
that's why you have to specify one or the
Okay.
other. And you're pretty good with that.
Yeah.
And if I said x is greater than 4,
You would, put an open dot on 4 and 0 and just connect those.
not 0. No, no,
Or not 0, no.
greater than 4.
Just,
Make sure you're on the right side of that.
yeah, just from 4 and then draw an arrow to the right.
And with an arrow on it like that.
Yeah.
The arrow says that it goes on to infinity.
Yeah.
And make sure that, does that reflect that? Yeah, that's x greater than 4. Or,
Yeah.
yeah, I'm sorry, that means that's any number as long as it's greater than 4.
Okay.
Not
Yeah.
4.
Uh-huh.
Graph this for me. X is greater than 4, or x is less than or equal to minus 4.
Okay. So for x is greater than 4, you would just draw an open dot on 4 and point arrow to the right. And then for x is less than or equal to -4, you put a dot, an enclosed dot on -4 and point it to the left.
With an arrow.
Yeah.
I remember doing these with you last year.
Mm-hmm.
Yeah.
I remember that, yeah.
You were getting pretty good at it, actually.
Yeah. It was one of my favorite parts of algebra, actually. Yeah.
All right. I have to kind of figure out how fast of a pace to move here.
Uh-huh.
So I don't want to spend too much time on any of these subjects, especially if I believe you know it.
Uh-huh.
So solve this inequality, and you can now do it however you want.
Okay. So we could add x to both sides. So
just read the next line to me. In other words, that's my two choices. Until you are doing it correctly, the way I'd like to see you do it is just read the next line to me.
okay. So you would get 5x minus 1 is greater than 14. And then the next line would be 5x is greater than 15. And then x is greater than 3.
All right.
Cool.
I actually think you're more comfortable with inequalities than you are equations.
Uh-huh.
You don't make that same mistake that you make with equations. When there's an equation, you're inclined to subtract one from both sides, but when it's an inequality, you never make that mistake. Or maybe it's just the fact that you've refreshed your knowledge of it today. And
yeah, that's probably it.
I don't think. Okay, let's go on to absolute value.
Okay.
Now, if it makes you feel any better, this is from an Algebra 2 book.
Okay.
Not
cool.
Algebra 1. So, but, I'm not sure that there's that much of a difference. I'd be hard-pressed to draw the line between Algebra 1 and Algebra 2.
Yeah.
So I think you'll like Algebra 2 next year when you get to it.
Awesome.
Okay, so let's take a shot at this. So what is this thing? This absolute value of the quantity 2x minus 5 is equal to 9. So no one thing. You're going to almost always have two solutions when you have an absolute value.
Yeah. Yeah.
So this means two things. What two things does this mean?
It means that there can be an absolute value of 9 and then an absolute value of -9.
When I say it means two things, give me two equations.
Okay, 2x minus 5 is equal to 9, and then 2x minus 5 is equal to -9.
Or.
Yeah.
And there is a distinction between or and and. It
Yeah,
actually would
because
be incorrect to put and there. In
okay.
other words, it's an or. It's either of these two cases.
Okay.
Okay, so if we solve this one, we get x equals 14 or 7.
Uh-huh.
If we solve this one, we get x
-7.
equals -2, I believe.
Yeah, -2.
Okay. So if I want to graph that on a number line, I'm either there or I'm there. One of
Yeah.
those 2 points. Both of those are solutions to this.
Okay. Yeah. Okay. Cool.
Okay, before we go, let's test
Okay.
our process here. These were the 3 that you didn't define properly
Okay.
the first time through. So, what's a rhombus?
Uh, a rhombus is well, it's like a quadrilateral with 4 equal sides.
That's the thing I want to hear first. 4 equal sides, quadrilateral.
Sides, yeah.
Okay, good. We can take that to
Okay.
the list.
Okay.
And now I'm going to draw 2 polygons and have you tell me which one is concave and which one is convex.
Okay.
Um,
The first one would be convex, and then the second one would be concave.
Other way around.
So the first one would be concave. Oh, I did that again. Yeah.
How did I teach you to remember it?
Um.
The only two,
It
use
was.
the C versus the V.
Yeah, that's right. Yeah, C
C
becomes
comes
before
first
V.
in the alphabet, right?
Yeah,
Well,
exactly.
it's not that I drew that first and that second. That, you're
No.
not always going to see that.
No.
But which of these polygons do you deal with all the time?
The one on the left.
Yeah, not hardly ever do you deal with the one on the right.
No.
They don't teach you those. You learn quadrilaterals, you learn pentagons, you learn heptagons, sexagons, all of them, and they're all concave polygons.
Yeah.
There's probably a much better technique for distinguishing between these two.
Hmm.
Oddly enough, when you get to calculus,
Uh-huh.
this irritated the heck out of me one time because in Colorado, this is called concave down.
And then
This
that's
is
concave
called
up.
concave up.
Yeah.
And they don't distinguish, they don't use the word convex.
Interesting.
Okay? But then I go and I take a test for calculus tutors to see if, you can do calculus tutoring. And
Uh-huh.
they're using convex on me instead of, and I couldn't quite figure out, convex was one of these two, but which one is it?
Yeah,
It's
exactly.
not clear which it would be, especially from
No.
our definitions of concave and convex polygons.
Yeah.
Still isn't clear. And to be
Interesting.
100% truthful, I'm not 100% sure which it is. I believe this is the same as convex, the concave down. And
Probably, yeah.
that is just called concave. But I'm not sure because the terminology is completely changed. It shows you where terminology really can be different math worldwide. Uh,
Yeah. Yeah.
it's and so terminology is kind of a key. But
It
just
is.
remember the concave. I just figured out a better way to memorize it.
Cool.
A cave surrounds you.
Uh-huh. Yeah.
You're not
Oh,
going to go
yeah.
into a cave that looks like this.
No.
So maybe that's a better way to memorize it. I don't know. Actually, a bear, you might go into a cave that looks like this. You might find a big old bear there.
Yeah.
You'd rather go into a cave that looks like that, right? Because you
Exactly.
see all dangers. That's a good way to memorize it, actually. You don't want to go into a cave where I can draw a line between there and there. That means I can't see what's over there.
Yeah.
Whereas if I go into a concave cave, there is
Yeah.
no place in that cave that I cannot see.
Exactly.
And that is true. Yeah. If I
Yeah.
draw this thing here,
Uh-huh.
I'm not going in that cave because when I walk in that door, I can't see what's right there. And this is a convex polygon.
Cool.
So it's all about being able to see every single place in the polygon. That makes it concave. That's the kind of cave you'd want to go into.
Awesome.
I put it
There
in
we
my
go.
book when I write
Perfect.
it. It's odd, but that is frequently the secret of mathematics is figuring out how to memorize this stuff.
Exactly, yeah.
The thing is that different techniques work with different people, so it's hard for me to give my techniques to everybody else. It may not work as well. But in this case, I think it is. That's this the way you should memorize.
Yeah,
Still
definitely.
doesn't answer what concave up and concave down are compared to convex, but
Uh-huh.
I think I had to look it up on Google, and it told me, but I forgot because I don't use it.
Oh my gosh. Gotcha.
All right, Dylan.
Alright.
Let's see when I've got. What's our next?
I believe is it Wednesday?
No, it's sooner than that. Hold on a minute.
Okay.
My calendar.
Or Tuesday. Tuesday. I keep thinking today's Monday for some reason.
Let's go to next week.
Okay.
Yeah, it's Monday at 11, and then again Wednesday at 11.
Okay.
And then Friday, it's at 5:30.
Okay.
And then again Sunday at 11 for half an hour. I don't know.
Okay.
Your mom must have made this appointment. Oh,
Yeah.
I'm not quite sure what happened here. Whether that should be a half hour or an hour, I don't know. You'll have to discuss that with your parents. And I think
Okay.
they're trying to find a sixth session.
Uh-huh.
Although that would be, we've done two, so this would be
Yeah.
5.5. This would be close. Yeah. Okay. So these 4 sessions next week should make everyone
Okay.
happy, I think.
Okay. Cool.
Okay. We'll talk to
Alright.
you at 11 on mañana.
Alright. Sounds good.
All right. Bye-bye.
Alright, bye-bye.